Good afternoon, everyone. Welcome back to Teach Me Now. Today, guys, we're coming back with another bang of a video, guys. I hope you all are ready, guys. I hope you guys are having a pen and a paper there. Without waste of time, guys, let's get down to our question, guys. So today's topic is based on application of calculus. So application of calculus is a topic from grade 12, right? Now, as per normal, let's jump to the statement. So PQRS is a rectangle with P. It's a rectangle with P on the curve. So P is on the curve, as you can see. Curve h of x is equals to x squared. So h of x is equals to x squared with the x-axis and the line x is equals to 6. So with that being said, 6 is the distance from 0 till that point there of R. So this is our 6. That's 6 units, right? And then, but now the point P. Point P is the line. Is a point of intersection between the curve and the rectangle, right? And the point of intersection, that's where two graphs are equal. So you can use either of the equations. You can use the equation of the first graph and the equation of the second graph. So with regard to this question, we can see that rectangle doesn't have enough information, but the curve has at least the equation, which is h of x equals to x squared. So now, as from there, guys, let's just use that information, right? So P, so point P in general, P is made up of x and y by definition, right? But now h of x is our graph. Graph is equals to y. So we can say y is equals to x squared. So with that being said, our P new now becomes x is to x squared, right? X is to x squared. And then as from there, which means now our P becomes x is to x squared even on the sketch. So x, so a distance from 0 to Q is equals to our x, right? And then the distance from Q going up vertically, so that's x squared, right? So now the small distance there, this one, that's 6x minus, oh, that's 6 minus x, sorry. That's 6 minus x, right? So now they said show that the area of the rectangle PQRS can be expressed as 6x squared minus x cubed. As soon as I see the cubic area of a rectangle, so I think of this. Area of a rectangle is length times breadth, right? Okay, now let's go back to our question. Let's go back to our sketch, sorry. Let's go back to our sketch and try to label our dimensions. So this is our length, and then this is our breadth, right? And we said QR, that's 6 minus x. And then we said our length, that's x squared, right? So now, equals to now the area. Our length we said is what? PQ. And then our breadth is QR, which is equals to our PQ, that's x squared. And then our QR, that's 6 minus x. So now we need to distribute x squared. So x squared times 6 gives us 6x squared. And then x squared times negative x gives us negative x cubed. Proven. So we've proven that that's correct. So that's question 10.1. Now let's go to 10.2. Now they said determine the largest possible area of the rectangle. The largest means maximum. So when I think of the maximum, I just go back to the graph, the polynomial graph on calculus, the graph, right? So here we get our maximum, and then here we get our minimum. So on our maximum, derivative is equals to 0. Even here, derivative is equals to 0 because that's our turning point. That's how we get x at turning point, right? So whatever the formula given to you, you need to derive that formula and then you equate to 0. So they give us the area as 6x squared minus x cubed. So now we need to derive that. So we have a derivative of a in respect of what? Of x. So now how do we derive this? We need to drop down 2 and then subtract 1. Drop down 3, subtract 1 as well. So when we drop down 2, we get 6 times 2 and then x. 2 minus 1, that's 1. Minus 1 times 3, and then 3 minus 1 gives us 2, and we end up getting 6, we end up getting 12x minus 3x squared, which is equals to 0. Remember I said the derivative should be equals to 0, and this is our derivative. And then as from there now, guys, we need to solve for x. So we can just divide everything by 3, right? After dividing everything by 3, we end up getting 4x minus x squared is equals to 0. And then we take out the common factor of x here. Now we're left with 4 minus x equals to 0. So that when we multiply this back, x times 4, we get 4x. X times negative x gives us negative x squared. And then as from there, we apply the rule a times b equals to 0. Therefore, a is equals to 0 or b is equals to 0. Therefore, our x is equals to 0 or 4 minus x equals to 0. And then now we transpose our x, and then our x becomes 4, right? But then now, this is not applicable because when we substitute 0 on this formula, we will get an error of 0. So we're looking for the maximum error. So the formula of the error we have 6x squared minus x cubed. So whenever we see x, now we substitute 4 so that we can get our maximum area or the largest area equals to. Now is our area max. Looking for our area max. We have 6 open bracket 4 squared minus 4 cubed. We get 32. So that's 32 units square. And we came to the end of our session, guys. Your tutor signing out.